You know how tough it is to give super precise instructions? Imagine that, but for software. Getting every tiny detail right for a program is difficult, and if you miss something, the software might not work as intended. This paper tackles exactly that problem.
Right A. Those precise instructions are formal program specifications, crucial for correct and secure software. But writing them manually is a huge headache, and even automated tools often produce specs that are too simple. SpecGen uses large language models, or LLMs, to automatically generate these high-quality specifications.
So, an AI writes the rules for software? That sounds powerful. How does SpecGen actually do it? Does it just guess, or is there a more structured way it figures out what the program is supposed to do?
It's very structured. The first phase is conversation-driven specification generation. Think of an LLM learning from a tutor. It generates specs, a verifier checks them, and if there's an error, the verifier provides feedback. The LLM refines its next attempt through this iterative conversation, as shown in Figure 2 and Figure 3. Figure 4 illustrates prompt construction.
That's smart. So it's not just a guess, it's actively learning from its mistakes. But what happens if the program is really complex, and even with all that feedback, the LLM still can't quite get the specifications perfect?
That's the second phase, mutation-based specification generation. If the conversational phase stalls, SpecGen takes the LLM's best, albeit flawed, attempt and applies mutation operators. Imagine a chef tweaking an almost perfect recipe. SpecGen systematically alters parts of the specification, like changing a greater than to greater than or equal to, or modifying how it handles quantifiers, as outlined in Table I. It then uses a smart selection strategy to pick promising mutated versions. Figure 1 shows how detailed these specs can be.
Okay, so it's a two-pronged attack. First, the AI refines through feedback. And if that doesn't work, it systematically generates and tests intelligent variations of its best guess. That sounds like a really robust way to approach this problem.
It is, and the results are very promising. SpecGen significantly outperforms existing tools like Houdini and Daikin, as well as other LLM-based approaches. We successfully generated verifiable specifications for 279 out of 385 programs. Figure 5 visually demonstrates SpecGen's broader coverage. A user study also showed SpecGen's output is semantically high quality, receiving an average rating of 4.54 out of 5, very close to human-written Oracle specifications, as shown in Table V.
That's impressive. But with any advanced AI system, there must be some limitations or challenges. What should people be aware of?
While powerful, LLMs still struggle with extremely complex programs, and verification itself can be intensive. There's also the ongoing concern of data leakage, though we took steps to mitigate that. It's an iterative process, and sometimes it takes several rounds.
So, SpecGen is making great strides in automating a really difficult but critical part of software development. By combining conversational AI with a clever mutation strategy, it helps ensure software programs have clear, verifiable instructions, leading to more reliable and secure code. A huge step forward.
Absolutely. It opens new possibilities for improving software quality and reducing the manual burden on developers, especially as programs grow in complexity. SpecGen represents a significant step towards truly intelligent, automated software engineering.